Hello, so welcome to this class for formulation of hypotheses. So in fact, a very important point in hypothesis testing is the formulation of the hypothesis itself. If we are successful in hypothesis formulation, so it will be more easy for us for testing and performing the examination or checking of our hypothesis. So now let's look for the steps which are required usually as a normal steps into our hypothesis formulation. So first of all, we should prepare some points. In fact, we should define our population which is under testing. Our population is usually a huge products, for example, or a huge amount of people. For example, the product of water bottles is a population. Also, the people in a university is a population, or in a city or in a country. So the product in any company or any production line could be a population. After defining our population, we should take a random sample. For example, we should be at random time and a random manner and choose random elements from this population. So this will be our sample. Our sample size will be of size n. So n is the number of elements, which could be 10 or 15, 20, 25, 40, 50. So the number of elements inside the sample is our sample size. The sample size could be any number we select. So after that, we will define clearly which property we are testing for. For example, in the population of water bottles, we can test for the capacity of the water bottle itself. Other people maybe would like to test for the weight of the water bottle or the height. So we should clearly define the property we are testing for. So after that, we should identify if we are testing for the mean or the average value of this property, or we are testing for the variability among the population for this property. If we are testing for the mean, so we are testing for the central tendency or the values which are concentrating around some point. For the variability, we will look for the variance of this population. So after preparation, we are going to formulate our hypothesis. So in fact, this is also an important step. So the formulation, in fact, firstly is to define our null hypothesis. The null hypothesis, in fact, is nothing more than our initial assumption. Our initial assumption, for example, for the mean value or the average of the property we are looking in this population. After that, we will define, in fact, the alternative hypothesis. The alternative hypothesis is the values or the region or the range of values that we are afraid or worried that the property have been changed into. For example, if the mean value have changed to some values above or lower the value of our initial assumption. So we can have here some examples. For the bottle capacity, we write now H0 or H0 that the mean value of the water bottle capacity is 500 milliliters. So this is our initial assumption or our requirement for the water bottle capacity. So this will be the null hypothesis or our initial assumption. In fact, we are worried or we are afraid that the mean value of water bottle capacity have changed either above or lower the mean value, which is 500. So we write H1, which is the alternative hypothesis, that mu is not equal to 500. So in fact, this is called a two-sided hypothesis. So now let's look for the integrated circuit temperature. Our initial assumption that the temperature of operation is 45 degrees centigrade. In fact, we are not worried if the temperature is below 45, because this will be fine for the operation of IC. We are worried if the temperature will exceed 45 degrees centigrade. So this is our worrisome here. We write H1, which is the alternative hypothesis, that the mu value or the average of the temperature will exceed 45. So in fact, this is called also a one-sided hypothesis because of the larger than. Also, for the swimming pool example, we have seen the antiseptic concentration, which should be maintained at least to 740 parts per million. So this is our initial assumption, or the mean value that the concentration should stay at. So we are afraid that, or we are worried if the concentration of this antiseptic will sometime be below this value. So we write H1, which is the alternative hypothesis, that the mean value of the concentration is below 740. This is also called one-sided hypothesis due to the less than in the alternative hypothesis. So now the important and the final step is to perform the test. In fact, we should have some calculations for our sample, such as if we are looking for the population mean, we are going to compute the sample mean. If we are testing for the population variance or variability, we are going to compute the sample variance. In fact, these steps we are going to see after that in this course. For example, one step is to compute the test statistics. In fact, the test statistics is a methodology to perform the test of hypothesis and to conclude the result. We will look later, in fact, how to use the test of statistics. After that, we should also choose the confidence level to perform our test. In fact, according to our confidence level, the conclusion may change. Useful or famous confidence level will be like 90% or 95% or 99%. We will look later what is the confidence level and how we can use the confidence level to judge or perform the test of our hypothesis. In fact, there is also two other methodologies to test the hypothesis, which are the confidence intervals and the p-value. We will see later how to use these methodologies to perform our test. After that, we can conclude the results. In fact, we eventually will reach either one of the following results. Our result could be that we fail to reject the null hypothesis. This means the null hypothesis is still statistically true and statistically valid. If this happens, so this means the mean value, for example, has not changed and stayed at the same as we have assumed. The other conclusion could be that we reject the null. If we reject the null, this means the null hypothesis is not true according to our test, and the mean value has changed to another values. So some other action should be maybe required at that position.